Hi, I'm Haylee and I'm here in collaboration with Casey and you're watching Fluids Lab 4 with lasers. For our Fluids Lab 4, we decided to look at total internal reflection inside laminar flow. In order to set up our experiment, which you will see next, we used a cup with a hole that was small relative to the size of the cup and 2 different laser colors.
One thing that we did to make sure that our flow was laminar, in addition to just having that hole be very small compared to the size of the cup, was making sure the hole that the water was coming out of was very smooth. So we melted that hole instead of cutting it out. That way none of the rough edges could trip turbulence. In our demonstration, you can see the laser pass through the clear cup and the fluid inside and into the beginning of the free jet of water. Then you can see the rest of the free jet seem to glow as the light is reflected internally in that portion of the water jet. Total internal reflection occurs when light is hitting a surface at lower than its critical angle and the entire light beam reflects instead of passing through the surface, in this case a fluid. We know that laminar flow is important for this phenomenon that you can see in the video because the laminar flow creates a constant surface that the light can then bounce off of, as opposed to turbulent flow, which can be considered more rough and more inconsistent, releasing that light instead of reflecting it.
One interesting thing we noticed when doing the experiment is you can see where the flow begins to transition to turbulent, because that is where the light begins to exit the flow of water. This is because the angle of the surface becomes more extreme relative to that of the light, and so the light is able to transmit through rather than be reflected.
Here's a version of our experiment that was done in a bit more of a controlled environment by Harvard. In these conditions, it's a lot easier to see how much the light can follow the bend of the water stream.
Thanks for watching!